between a small pump and a larger pump over here. Basically, we have a pump here that's about a 30 horsepower pump, and the smaller pump, which will maintain the ice sheet almost 90% of the total operational time, may be only a 2 horsepower pump. So there's a tremendous amount of energy savings that can result from that type of application. After this is all assembled and pressure tested, you can see here as far as the components that we use, most of the materials we use for the manifolds are all Schedule 80 PVC. The system itself is a low working pressure system, so the PVC is a very cost-effective way of creating the piping system as opposed to doing Schedule 40 welded steel pipe. The working pressure in the system typically is only about 25 psi. And they'll assemble this, get it pressure tested, and then we'll paint it, and it'll be ready to ship. This one, I think, is going out to Gurney Mills, Illinois, in fact. Okay. Over here, some other components we throw together as a company. Without the nets on them, maybe you wouldn't know what these are, but until they get painted, they'll look like a hockey goal frame. And we do NHL hockey goal frames and ship these all over the world as well. We bend the piping, weld the wire on, then they'll be painted with a high impact resistant epoxy, and then we'll ship them loose with the nets, and the people who usually buy them end up installing the nets on them. Over here, after the process of all the panels being galvanized, they're shipped back to us on the dashboard panels, and you can see how we get these back all galvanized. At this point, these are staged, waiting to go upstairs, and we have two different locations in our shop. We have a dirty room right now, and we have what we call a clean room. By nature of cutting steel, welding steel, and grinding of the steel, it's a dirty environment. Under the best case scenario, you can't keep it clean. Where after we have the panels galvanized, the steelwork galvanized, we take that up to our upstairs area, and we call that our clean room. And that's where we do the finished work, so we keep everything spotless by comparison to the downstairs area. So why don't we go upstairs and we'll take a look at some more fabrication work that takes place upstairs. Now we're upstairs in what we call our clean area, and you're going to see a bunch of dust and material around from the cutting and the shaving, but it's a different type of dirt. It's not a type of dirt that discolors the material, so that's why we call it our clean area. And what I'm going to introduce you here, this is a new product line that we recently came up with and got patented, and it's been very, very popular in both the ice and the inline industry. This is called our batterboard product line. And as you can see here, this is how the raw material comes. And what we did downstairs, and you saw, is the old style of making a dashboard system was we cut steel, we weld steel, then we galvanize steel, and then we put a facing on it. Very labor intensive. The raw material cost to the overall labor ratio is not very high. So what we wanted to do is we wanted to get a more cost-effective way of making a board system, be more competitive in the marketplace, and also, of course, make us more attractive against the competitors in the industry. This product is a pultruded fiberglass material where the whole dashboard system, including the structural members that you can see here, and the facing itself, are all extruded as one process. And it's an 80% fiberglass content. It's a material that's very, very hard. It has a 30,000 psi tensile strength. It has a higher strength to weight ratio than steel does, or even aluminum. In fact, as you know within a lot of industries, is that composites are taking over a lot of the conventional steel manufacturing principles. This is essentially the same type of material and technology they use for high-performance aircraft wings and for hockey stick handles or golf handles that many of you probably have. What we do with this is we get this from a subcomponent, sub-supplier rather, that makes the component for us. We own all the tooling as well. They extrude it, very much like the aluminum extrusions were downstairs, but this is all out of fiberglass. After we get the raw material in that fashion, we use diamond tip cutting devices that cut the panels to specifically to length, and then we fabricate them with some of the other components that we need to make the finished product. We take the raw material and we install what we call a kick plate, for example, in the ice hockey industry. And the reason we need a kick plate, which is made out of polyethylene, is we need a wear plate on the bottom of the dashboards. You have a Zamboni that runs around the rink, and you also have skate wear from the kids kicking the dashboards and things of that nature. And by putting on a wear plate like this, it gives us a wear area that can be replaced over time. Typically, it'll last about 2 years, and they'll be replacing the kick plate. And they drill this with special drill bits, and then they go ahead and install the kick plate. Bob, do you have anybody show how the handrail and everything goes together here? We use polyethylene for most of the subcomponents on top of the batterboard system. The polyethylene is a very cost-effective material that has a good durability from impact resistance. The only areas that we don't use the polyethylene is for outdoor applications, which was another reason why we came up with the batter boards. When we do outdoor rinks, temperature variations play a big role in how materials expand and contract. One challenge for us for the inline industry, which is ever popular in park and rec departments and putting these things up just about everywhere, is if we use polyethylene outdoors, which work well indoors but not well outdoors, we found that the polyethylene expands and contracts at a tremendously high rate. For example, if we took a full 200 by 85 foot rink and used the polyethylene materials, under a 75-degree temperature change, which is simply from summer to winter, that dashboard system would literally be trying to grow or shrink 58 lineal inches. Now, when we use the batterboard material only expands and contracts under those same temperature conditions by only 1.2 inches. And that was a design challenge that was very important for us and what really initiated the design behind the batterboard system originally. We use simple fasteners, not very complicated, but as you can see here with this type of panel versus the metal panel, there's virtually no labor whatsoever that goes into the panel. Panels come in raw material, they're cut to length, we put a handrail, we put a kick plate on, they ship out the door. The only other panels that require some additional work are the panels where the doors are located in. The panels themselves are made in all integral 8-foot lengths, so they're interchangeable, and the reason behind that is any panel can go anywhere. Anywhere there's a straight panel can go in. Anywhere there's a curved panel, the curved panel can go in. Equally, the doors, which are also manufactured into 8-foot straight sections, they can be relocated throughout the rink as required for different layouts. These are all plated stainless steel screws and nuts with a lock nut on them so they don't come out after a period of time. We mentioned how strong the batter boards were and their strength to weight ratio. I think sometimes people, when they see the profile, they don't realize how strong this material really is. Here you can see it's just a small straight section of panel and how strong it is in not deflecting at all. We've even taken automobiles up on it, the weight of an automobile, or taken as many as 6 people on top of these type of panels and done the same type of test, and there's hardly any deflection whatsoever. One may ask that if they're this rigid, how do you deal with the radius and how do you deal with the curves that you see in a hockey rink? Well, it's very easy, and we want to show you how that works. The panels are strong because of the ribs in the back of them. When you look at a panel here, you'll see what we've done is we've developed a process of putting saw cuts through the structural members in the back at intervals of 6 inches. And what that enables us to do is take what would normally be a very strong, rigid, straight panel and convert that into any curve or radius that we need to. We use a diamond-tipped saw blade that simply cuts through everything but doesn't cut through the facing, as you can see right over here. We leave the facing totally intact but cut through the ribbing. The profile design in the batterboard structure was set up so we can take a stainless steel tube, as you'll see here, and bend it to any radius that we want to use this for. Now, we've bent these panels as tight as an 8-foot radius for use in skateboard parks, which is another product line and market that the batterboard panels will be used for. This is bent to approximately a 20-foot radius, which is typical of an inline skating rink application, and we're going to show you how a straight panel like this is almost immediately converted into a radius panel. Now, this is work that's normally done in the field so the panels can ship flat. Okay. And it's as easy as that. Now you have a panel that's bent to meet a radius, and that'll bolt through, and all the support members would normally bolt up behind this panel, and you have your curve, and it's that fast and that simple. Another neat feature about the batterboard system and design is that everything attaches to the back of the panel and there's no facing penetrations whatsoever, where conventional construction of years ago, when they weld steel, galvanized steel, and put the facing on, as mentioned, they'd have to drill through all the facing materials to attach it mechanically to the framing, where the batterboard creates a very nice, smooth transition around the whole perimeter of the rink. It's very attractive and it's safe and low maintenance as well. The process of cutting through the panels is not that complex either. Maybe we can have somebody show here how that all works. Essentially, we use a standard circular saw, but when you look at the saw blade, you can see this isn't a standard saw blade. Because this material is so hard at 30,000 psi tensile strength, it's equal in strength to low-grade steel. Steel typically is anywhere from 30 to 50,000 psi. So this is a very hard material. If we use a standard saw blade, we're lucky if we get a few inches into the material before the blade's essentially shot. So this blade is coated completely with diamonds. And go ahead and demonstrate how that's done. We use basically just a straight edge to make sure that we don't go through the facing itself or create score marks which would be unattractive from the back side. And that's how all the saw cuts are done. Yeah, let's go ahead and show that too. For the processes of the doors, where they have to notch out for those inset frames, they use a grinder, and they just take the T off the rest of the way. We have the ventilation system shut off. It's a little dustier than normal, so we could hear in the video. But that's the process of cutting the fiberglass. Another process, after the panels are cut, fabricated the way they need to be, we put the final touches on it. If we're using these for an ice hockey application, we put the polyethylene wear kick plate and handrail on it. If it's being used for the inline application, which is a more cost or more austere type market that can't afford those type of luxuries of the more expensive polyethylene arrangement, they still like to have the feel of a real hockey rink. So we use a process of a two-part epoxy and paint on what looks like to be a handrail and a kick plate when there's really not a separate part for those type of areas. That requires a totally dust-free condition. As you can see with cutting the fiberglass earlier on, we would never want to be painting the same time we're cutting or fabricating any of the fiberglass. Otherwise, we'll have that fiberglass dust incomplete throughout the paint process. But you can see here how they've applied the tape for where the kick plate would be applied and also for where the handrail would apply. And here's a small little sample that gives some demonstration of what the finished product looks like then afterwards. Canary yellow, typical kick plate. Red handrail, typical handrail. Of course, we do any color that the customer would want, but those are pretty typical to the industry and what we all know as being an ice rink color. For the applications where we're doing the kick plate, we use a simple table saw for cutting the polyethylene. And we get raw sheets, 4x8 sheets of polyethylene in the various thicknesses, being a 1/4 inch thickness or 3/4 inch thickness for the handrail, and cut those into the appropriate widths. We usually order our polyethylene by the truckloads as far as pallets, and we still also stay with pretty much standard colors, our typical royal blue, red, yellows, and sometimes we get a canary gold color, which is more popular in the Canadian marketplace. See, this is cut for a kick plate width, which is 1/4 inch in thickness, 8 inches high. And then this will be countersunk with a drill and mounted to the panels themselves. As you can see, to put a hockey rink together, there's an awful lot of parts and pieces. Why don't we head over and look at the piping systems and show how those are assembled. The rink piping system we make are for both portable and permanent applications. In portable applications, we have a product that we call our porta pipe system. And porta pipes are used for people like Disney on Ice, Holiday on Ice. They're used for various ice shows where they can literally put the whole rink in a day and take a whole rink out in a day. Or they can do smaller rinks for like theater stages where they'll do anywhere from a 40x40 or 60x80 type surface. But that's been a very, very popular product line for us as well. Here's a product that's fully shrink wrapped and ready to go, and this one, as you can see here, is going to Aberdeen, Scotland. And we pride ourselves very much on being an international company. We just did a project over in Cairo, Egypt. We've done a bunch of work in Korea, Europe, just about everywhere. Many people